with your mentor Avilash Sarkar. Now in this chapter I will continue from problem number 30 in binomial series. So problem number 30 is, can you see it? Prominent. Okay. Now yeah, okay. So problem number 30. Okay, we'll take this. It says sum of the last 30 coefficient of the last 30 coefficient of power of x in the binomial expansion one plus x whole to the power n whole to the 59 is how much? Okay, so it says you have to find the sum of the last 30 coefficients of power of x in the binomial series. So let us discuss the thing seeing the binomial series first. Now what we can see, the first thing is that this power is odd in nature. So the number of terms will be 59 plus 1, that is equal to 60. Now this is even. The first thing is understood. This is odd. Number of terms, if I expand it, I will get even. Now this is 30, this is 30, this will be 30, this will be 30, number of terms. So there will be two middle terms, one will be 30th, one will be 31st. By seeing the similarity, we can assume in order to calculate it by the formula and all that. By seeing that, you already know it. So now any series whole to the power n, when you expand, the binomial coefficients are, in this case if I see, it will be go like that, dot dot c, how much will be the end one? C0, it is starting from C59 will be the end one, Cn and Cn, and x to the power n will be the last term. Now the binomial coefficient will specifically, if we talk about the first one thing, you know, the sum of odd binomial coefficient plus this is sum of, if I talk about only the sum of all binomial coefficient is nothing but sum of odd binomial coefficient plus sum of even binomial coefficient, that we have proved already. Okay, this is summation of odd position binomial coefficient, and this is and plus of even position binomial coefficient. When if I put 1, that will go. So this is sum of the binomial coefficient. Another thing is true, if I don't represent it in the form of odd or even, in other way we can put it, and that will be what? If I put, let's say x is equal to 1. So one thing we know, this is the sum of the odd and sum of the even. This is one way of representing this. Other way of representing this is what? First half of the binomial coefficient plus last, this is first half of the binomial coefficient in plus second half of the binomial coefficient, that we can say also. because here we are not adding anything or subtracting anything, and that's because this is you getting equal numbers. In case only this is odd and the number of term is even, you can distribute it into two way. Either you add odd terms that will give you 30 and even terms that will also give you 30, or else if you can take down first half and second half, that also will distribute into equal number of terms. The first thing you understand that this also is the first half of the binomial coefficient and second half of the binomial coefficient. How you can say that? Because if we see the value of the coefficients from the either end equidistant are same, so that means this is equidistant from equal to this, the first and last term. Similarly, this or all the consecutive terms taking from the back side also till we reach there will be all same. So this is just a mirror image of these two. So that we can say one way the sum of odd position, that also will we have proved by this theory, and by logically also, as because it's a mirror image, this is nothing but just mirror of this. So this is twice of this, we can say first 30. Understood? So this 2 to the power n, again we can say 2 part of the first half or 2 part of the second half, that we can say. So what you need? The sum of the last 30 coefficients. So if I can say this also, that this is sum of the last 30 coefficients, that means second half is 2 into the second half is equal to 2 to the power again. That is also the same thing. Now the second half, that means the last 30 coefficient. We are talking about on the coefficient because we have eliminated by taking x is equal to 1. The last 30 coefficient is equal to how much? 2 to the power n divided by 2. So that is 2 to the power n minus 1. So this is only possible in case the power is odd and number of term you will get even, so that you can distribute it in equal parts. And by the logic, either you can make it the sum of odd terms plus sum of even terms, or the first 30 terms to the last 30. That means equally you can divide. In this case it is 30-30, in other cases also it will be equally divided. And if you take as a reference of as a mirror, this will be just the replication. This is a mirror image, you can say. So the first term is equal to last term, the second term will be the second last term, and similarly till you reach there you will get all the terms are equal, and if you add this you will get equal. So either you can say that 2 half of the first 2 times the first half or 2 times of the second half. Now if it is the result does not change, so the result is same, so the last 30 terms is 2 to the power. Understood? Okay. The next is 31. The coefficients of x to the power p and x to the power q, where it has said that p and q belongs to integer, positive integer. Basically in the expansion of 1 plus x whole to the power p plus q are what? Means you have to establish some relation between their coefficients. And now seeing the coefficient you can establish. So first, we have to find the coefficients of x to the power p and x to the power q. So our general rule of any term in an expansion, if we assume that this is t r plus 1, so naturally this comes as the n here is p plus q, c r, and first term to the power p plus q minus r, and second term to the power r. So now you, in case if you want to get x to the power p, so what you will get? P plus 1th term, so this will give you c p, 1 to the power anything, doesn't matter anything, so that will give you ultimately. Similarly, t q plus 1 will give you x to the power q, and the coefficient you will get tq x to the power q. Now as per the condition, these and these are, you have to decide how it is being related. Now let us work with this. Now to find the relation, you can expand it, or if you see the terms minutely, by the rule you can establish the relation. What is the relation? If this and this, whatever you are seeing there at the bottom part of the combination, that representation, that means NCR, if this or any other case R1 and NCR2, if R1 plus R2 is equal to N, then we can say these and these are equal, or else if I say this and this is equal, then definitely either R1 is equal to R2 or R1 plus R2 is equal to the highest power. Now here you see what is the condition. This and this we are not knowing what is the relation, but you can see the term specifically. So if we add p plus q, whether we are getting this one, yes we are getting, so definitely you can say p is equal to cq. So that means the term which is containing xp and the term the coefficient which is having with xp and coefficient which is having with xq are equal. So that means the coefficients of the consecutive of these related terms are equal, because one does not changes any value. So any power of 1 is 1. So both the cases 1 will be 1, and all they remain with the binomial coefficient only. So binomial coefficient of these two terms, we can see it is equal, as p plus q will give you this power. Okay, the term of this and this together will give you the whole power. Okay, so in that concept we can say this is equal. Okay, so we move to the next problem. (32). If the coefficient of middle term, if the coefficients of middle term in the expansion of 1 plus x whole to the power 2n plus 2 is p, and the coefficients of two middle terms middle terms in the expansion 1 plus x whole to the power 2n plus 1 are q and r, then find the relation between p and qr. Then find relation between p, q, r. Whereas their option being given, this line, the last line I have added, because I will not go with the option, I will better go from the beginning of the sum. Okay, and we will try to proceed to the ultimate relation that is coming automatically. Okay, so if you see the first expansion, the power it is containing is 2n plus 1. So this is anyhow a even number. So in first expansion, if I expanded, this 2n plus 1 is even. So definitely the term I can distribute it in equal parts and middle a separate part, because the expansion will have 2n plus 1, 2 plus 1, this number of terms. So your middle term will be 2n plus 2 by 2 plus 1. That you can also decide by making n plus 1 this side, n plus 1 this side, and 1 will remain at the middle. So then it will give you 2n plus 2 plus 1, 2n plus 3. That anyhow that is coming. So from your logical approach also you can find, or you can use your formula. Okay, so 2n plus 1, 2 plus 2 by 1, this will be the middle term. So this is equal to tn plus 2. Okay, so tn plus 2 in the expression, what you have, what is given, the term in the expansion, the coefficient in tn plus 1, n plus 2 is in this expansion is how much? 2n plus 2 c n plus 1, because this 2n plus n plus 2 term, and 1 to the power something, 1 does not matter. So this will be your coefficient, and this is equal to given as p. So I will write it somewhere here as 2n plus 2 n plus 1 is equal to p. So this is my first equation. And coming to the next, where there are two terms, because 2n plus 1 is definitely a odd term. So number of middle term I will get how much? This will be this will give you number of terms 2n plus 2. So that means n plus 1 both side, and there will be no different middle term. So we can choose the extreme term from the both end, or the consecutive terms here after reaching this term. This will be, so what is this term? This will be n plus 1th term and n plus 2th term. Okay, by the logic you can also get it, because this will be the nth plus, because number of terms is n plus 1, so this is n plus 1th term, and the next one will be n plus 2th term. So it will be very easy. You need not to remember the formulas. If you understand the logic, you will get it easily. So tn plus 1th term of this series will be 2n plus 1 cn. This will be the coefficient, and for this one it will be 2n plus 1 cn plus 1, and respectively this is given as q and r. So now you have to establish some relation in between. Okay, so now seeing this, can you say what is the relation? This is n plus 1. This also follows some rule. We have already seen NCR plus NCR plus 1. What we can see? We can say n plus 1 CR plus 1. Can you see that this formula we already learned during our theory part? So if I use this formula, is this following the rule here also? Now instead of n, if I put 2n plus 1, instead of n, if I put here in the formula 2n plus 1 and r if I put n. Now whether this formula represent these terms, let's see. Now instead of that, in this formula I am putting n is equal to 2n plus 1. So I am putting 2n plus 1, r I am putting n. So this will be 2n plus 1, this will r is equal to n plus 1. Is this matching this term? 2n plus 1 c n, 2n plus 1 c n plus 1. So this we can say this is nothing but this term is your q and this term is your r. So q plus r this side on the left side, and what is this? Instead of n I am putting 2n plus 1. So this will turn into 2n plus 2 and r I am putting n. So this will give you n. So is this matching this term p? So this is definitely p. And in order to calculate separately, as we know, you can already say, as we know, the formula is ncr plus ncr plus 1 will give you n plus 1 cr plus 1. That we already proved. Here instead of n you put 2n plus 1. So you replace the value. Instead of n you put 2n plus 1 and r you put n. So you will get this one. So the relation establishes like q plus r will give you p. So this is the relation between their coefficient in the expansion. Understood? Okay, I will end up here this session, and the next session I will move to number 33. Thank you.